At its peak, Grand Coulee Dam was consuming 1 cubic yard of concrete every 4 seconds, 24 hours a day, 7 days a week. 2 mixing plants the size of 10-story buildings fed 8 mixers simultaneously, while a single operator ran each plant by pushing buttons. Diesel locomotives hauled 4-yard buckets across steel trestles that rose 175 feet above the riverbed. Those trestles were never meant to come down. They were designed to be buried alive inside the rising concrete, thousands of tons of structural steel entombed forever inside the largest man-made structure in the world. The dam used almost 12 million cubic yards of concrete, enough to build a highway from Seattle to Miami with a sidewalk alongside. Hoover Dam, which we covered in a separate documentary on this channel, used 3.25 million cubic yards. Grand Coulee used nearly 4 times that amount, and it did it while diverting a river that carried 16 times more water than the Colorado River. This is the story of the machines that built Grand Coulee Dam. We are going to cover this story in 5 parts. First, how they moved the earth and tamed the Columbia River. Second, the concrete operation that broke every record in construction history. Third, the machines and the men who ran them. Fourth, the human cost and the wild culture that grew up around the dam site. And fifth, how a dam that Congress called a white elephant ended up powering the atomic bomb and winning the Second World War. By the end, you will understand why Grand Coulee represents the exact moment American construction equipment evolved from the cable and canyon era into the industrial scale systems that would define the 20th century. The story begins in 1933 in a remote valley in eastern Washington state, where the Columbia River cuts through a landscape of basalt cliffs and sagebrush. The nearest town of any size was Spokane, nearly 90 miles to the east. The idea of building a dam here had been floating around since 1918, when an Ephrata lawyer named Billy Clapp first proposed it. For 15 years, a newspaper editor named Rufus Woods at the Wenatchee Daily World and a self-taught engineer named James O'Sullivan had been lobbying anyone who would listen. O'Sullivan neglected his law practice and his family for decades to push the project forward. When Franklin Roosevelt finally approved funding in 1933, he authorized only a low dam, 290 feet, for power generation only, no irrigation. The full price tag of $450 million was more than the Panama Canal had cost, and Congress was not about to approve that during the Depression. On July 16, 1933, a groundbreaking ceremony was held at the dam site. Chief Jim James of the San Poil tribe participated in the event. He had no way of knowing that this ceremony marked the beginning of the end for Kettle Falls, a fishing site his people had used for 9,000 years. We will return to that story later. The first contract went to WWII, a consortium led by Silas Mason, Walsh Construction, Atkinson Kier, and a small company called General Construction. On June 18, 1934, bids were opened at a civic event in Spokane. Factory whistles blew across the city. A pilot named Nick Mamer led an acrobatic air show over downtown, and a construction-themed parade marched through the streets. MWAK came in at $29,339,301.50, nearly 15% lower than the competing bid from 6 companies, the group that had built Hoover Dam. Among the other submissions was one from Hollywood actress Mae West, containing nothing but a poem and a promise to divert the river. Before a single bucket of concrete could be poured, the builders had to solve a problem that dwarfed anything faced at Hoover Dam. The Columbia River at Grand Coulee carried a peak flow of over 500,000 cubic feet per second. At Hoover Dam on the Colorado, the peak flow was roughly 32,000. That meant the Columbia was pushing 16 times more water through the construction site than the Colorado had pushed through Black Canyon. And unlike Black Canyon, which was a narrow slot between steep rock walls, the Grand Coulee Valley was nearly a mile wide and composed of deep gravel overburden sitting on top of bedrock. The solution was a series of U-shaped cofferdams built from interlocking steel piling, filled with rock and earth. The West Cofferdam alone stretched 2,000 feet, stood 110 feet above bedrock, used 17,000 tons of steel piling, and enclosed roughly 60 acres of riverbed. 1,200 workers built it in approximately 90 days, finishing on March 23, 1935. If you enjoy learning about the heavy equipment that built America's greatest structures, take a moment to like and subscribe so you do not miss our upcoming documentaries on the machines behind other legendary construction projects. The man running the show on the ground was Harvey Slocum, WWII's construction superintendent. Slocum was a partially crippled former ironworker with an 8th grade education who had already built dams at Gibraltar, Exchequer, Hetch Hetchy in California, and the Madden Dam in Panama. In 1956, the Moles Engineering Society would declare him the best dam man in the world, crediting him with pouring over 20 million cubic yards of concrete across his career. Slocum's toughness was tested almost immediately. In the spring of 1935, the Columbia surged 32 feet above normal. One night, the West Cofferdam suddenly ruptured, with 15,000 gallons per minute pouring through the breach. Slocum rushed to the site in his red pajamas. His men threw anything they could grab to plug the hole: mattresses, canvas tarps, building materials, even sagebrush ripped from the hillside. They held the line with improvised barriers until additional steel pilings and a thick paste of bentonite clay finally sealed the gap. Meanwhile, 22 million cubic yards of overburden had to be stripped from the dam site before foundation work could begin. WWII built a conveyor belt nearly 2 miles long, the longest in the world at that time, to haul excavated material to Rattlesnake Canyon for disposal. The belt lifted material 600 feet in elevation and carried 52,000 cubic yards per day. Caterpillar equipment dominated the site. There were 21 times as many Caterpillar machines as all other makes combined, including some of the first diesel track-type tractors ever produced, the 8th and 13th Caterpillar diesel. 60 models off the assembly line worked at Grand Coulee. Their first year's operating cost versus 2 competing gasoline tractors showed $3,000 in savings, roughly $60,000 in today's money. Caterpillar diesel. 75 tractors pulling scrapers made the largest excavations on the north section, and 5-yard electric shovels worked alongside Marion 151M drag lines with 6 cubic yard buckets and 125-foot booms. Here is where Grand Coulee's geology delivered a surprise. Contrary to what many sources claim, the dam does not rest on basalt. The site sits at the geological boundary between the horizontal basalt flows of the Columbia Plateau to the south and the granitic mountains to the north. The foundation is composed of 2 types of granite, confirmed by geologist William H. Irwin in a 1938 paper. The Washington Water and Power Company, which opposed the dam, had planted false rumors that drilling found no granite beneath the site, only clay and fragmented rock. Bureau of Reclamation drilling teams disproved this with 33,000 feet of diamond drill holes and 18 calyx drill holes extracting 36-inch diameter cores to depths of 29 to 68 feet. Workers were lowered into test holes 30 to 200 feet deep to personally inspect rock quality. 3 deep gorges were discovered in the bedrock, one extending to elevation 761 feet, meaning some areas required excavation nearly 150 feet below the general riverbed level. Then came one of the most consequential decisions in American construction history. In June 1935, Secretary of the Interior Harold Ickes signed a change order directing WWII to build the foundations not for the low 290-foot dam that Congress had approved, but for a 550-foot high dam. It turned out that raising a low dam later would be structurally impossible. The original design had always included an option clause allowing the switch with 30 days' notice. Evidence that Bureau engineers, including Chief Design Engineer John L. Savage, intended the full dam from the very beginning. Congress formally authorized the high dam under the 1935 Rivers and Harbors Act on August 30, 1935. The project budget jumped from $63 million to what would eventually reach $163 million. But the geology threw one more challenge at the builders. During excavation of the east abutment, a 200,000 cubic yard mass of glacial clay began sliding into the work area at 2 feet per hour. Engineers borrowed an old Prussian mining technique. They drove 6 miles of 3-inch refrigerating pipe into the sliding mass and circulated ammonia solution cooled by 2 large refrigerating machines purchased second-hand. The clay froze solid at 0 to 10 degrees Fahrenheit, creating a frozen arch dam 40 feet high, 15 feet thick, and over 100 feet long. It held the hillside together for 7 months, while excavation continued beneath it. Cost was roughly $30,000 versus an estimated $1 million in construction delays without it. This was the first use of a frozen earth dam in American dam construction. Now we reach the heart of the story and the second phase of our journey through this project, the concrete operation. Everything up to this point, the Cofferdams, the conveyor belts, the frozen hillside, was preparation for what came next. On December 6, 1935, Governor Clarence Martin of Washington pulled on rubber boots, climbed into a muddy pit, and spread the first bucket of concrete. WWII handed him a check for 75 cents. That was 1 hour's wages for a common laborer. The concrete system centered on 2 octagonal mixing plants, nicknamed the House of Magic, one on each side of the river. Each plant stood over 100 feet tall and 44 feet wide, containing 4 4-yard mixers. A single operator ran each plant by pushing buttons. Electrically operated devices automatically weighed water, cement, sand, and 4 sizes of gravel, while graphic recorders tracked every component and the consistency of each batch on paper. This was an early form of industrial quality control automation, and at the time, nothing like it existed anywhere in the world. Each plant could produce 640 cubic yards per hour. Combined, the 2 plants had a theoretical capacity of over 15,000 cubic yards in a 24-hour period. Concrete traveled in 4-yard bottom dumping buckets, each holding roughly 8 tons, loaded onto railway cars, 4 buckets per car. 14 Davenport 10-ton diesel-electric locomotives, serial numbers 2203 through 2212 and 2219 through 2222, hauled these cars across 2 steel trestles, averaging 95 feet and 175 feet in height, and stretching 3,000 feet across the rising dam. Several of these Davenport locomotives survive today. Cranes traveling on the same trestle tracks picked up buckets and swung them into the 50 by 50 by 5 foot concrete forms. And here is the detail that separates Grand Coulee from every other dam ever built. Those trestles were deliberately designed to be consumed by the dam itself. As concrete rose around them, the steel structures disappeared forever inside the mass. Thousands of tons of structural steel remain permanently entombed in the dam to this day. The cranes placing concrete were Clyde-Wiley whirley cranes, manufactured by Clyde Iron Works of Duluth, Minnesota, in collaboration with the Dayton Whirley Company. Built in 1935 specifically for Grand Coulee, each weighed approximately 230,000 pounds stood as tall as a 10-story building, and could rotate a full 360 degrees. At least 2 whirley cranes and 2 hammerhead cantilever cranes operated simultaneously on the west side trestles. One of these whirley cranes has a remarkable afterlife. After dam completion, it was transported by barge down the Columbia River to Henry Kaiser S. Richmond Shipyard, No. 1, in California, for wartime shipbuilding. It survives today beside the SS Red Oak Victory in Richmond, California. It may be the only piece of Grand Coulee construction equipment still in existence. The records tell the scale of what these machines accomplished. 1 million cubic yards was reached on August 14, 1936. 2 million by April 15, 1937. 4 million in less than 2 years from the first pour. The single plant daily record hit 9,290 cubic yards. Both plants combined once placed over 15,000 cubic yards in a single day. The monthly record reached 536,000 cubic yards. In January 1938, MWAKS contract ended, and a new consortium called Consolidated Builders Incorporated took over. CBI was led by Henry J. Kaiser, the Oakland industrialist who would later become famous for his wartime shipyards. The CBI consortium included Morrison Knudsen of Boise, J.F. Shea Company, Pacific Bridge, Utah Construction, and General Construction of Seattle. They inherited MWAKS equipment fleet and expanded it. 3 additional Davenport diesel-electric locomotives, serial numbers 2273 through 2275, arrived in early 1939. CBI pushed the pace even further, breaking MWAKS' earlier record of 377,000 yards with 400,000 cubic yards in September 1939 alone. When all was said and done, CBI returned $16 million in savings to the United States Treasury. To prevent the massive concrete structure from cracking as it cured, over 2,000 miles of 1-inch thin-wall steel tubing were embedded throughout the dam, spaced 5 feet apart vertically and 5 feet 9 inches horizontally. Cold Columbia River water was pumped through these pipes, followed by refrigerated water, reducing internal concrete temperature from 105 degrees Fahrenheit to 45 degrees. Without this system, the concrete would have taken an estimated 125 to 200 years to cool naturally. The cooling caused the dam to contract roughly 8 inches in total length, opening tiny cracks between adjacent blocks. Those gaps were then sealed by forcing grout through an embedded pipe system, transforming the dam into a single monolithic mass. This cooling pipe technique originated at Hoover Dam in Oregon in 1931, was refined at Hoover Dam with roughly 300 miles of pipe, and then was scaled up 6.7 times at Grand Coulee. If you have watched our documentary on the machines that built Hoover Dam, you will remember that Hoover used 5 aerial cableways to deliver concrete across the narrow Black Canyon. Grand Coulee could not use cableways because the valley was nearly a mile wide. The shift from Hoover's cableway system to Grand Coulee's trestle and rail system represents one of the most significant changes in concrete dam construction methodology in the 20th century, driven entirely by the difference in terrain between the 2 sites. Cement arrived in bulk boxcars from 5 plants across Washington state, was stored in 11 steel silos with a total capacity of 55,000 barrels, and then was transported to the mixing plants through an 11-inch pipe stretching 6,200 feet using compressed air. Total cement consumed across the project exceeded 12 million barrels. The aggregate processing plant, located a mile and a half below the dam on the east side, processed 2,500 tons per hour. Roughly 50% of all excavated material was rejected, creating a waste sand pile of over 10 million cubic yards that rose almost as tall as the dam itself and remains visible as a geographic feature today. We have now covered the earth-moving and the concrete. The third part of our story is the railroad that connected everything together. The Grand Coulee Dam Railroad ran 28 miles from the Northern Pacific Railroad at O'Dare, Washington, to the dam site. David H. Ryan Construction Company built it in just 5 months, driving the Golden Spike on December 8, 1934. The final 2 miles descended a 5% grade from Mason City to the dam, requiring Lima Shea geared locomotives, including Shea No. 3, 1295, built May 27, 1926, the first Shea used on this brutal grade. The locomotive roster included an Alco II 10-2 T-tank locomotive weighing 134 tons, a Baldwin consolidation that had formerly been Southern Pacific No. 2673, and the fleet of 14 Davenport diesel electrics that hauled concrete on the dam itself. On Christmas Day, 1941, 2 weeks after Pearl Harbor, Shea No. 801 was pulled back into service to replace a lighter diesel. It is a small detail that signals just how urgently the dam's completion was being pushed in wartime. The dam's spillway stretches 1,650 feet wide, with 11 drum gates, each 135 feet long and 28 feet high, fabricated by American Bridge Company. Maximum spillway capacity is 1 million cubic feet per second. If fully discharged, the energy at the toe equals 32 million horsepower. 60 outlet conduits at 3 levels provide additional discharge capacity. 18 steel penstocks, each 18 feet in diameter, feed the turbines. Western Pipe and Steel Company of California fabricated them on site in a football field-length assembly building. 16 million pounds of steel arrived as semicircular rolls sized to fit through railroad tunnels, then were welded into full cylinders at the dam. That assembly building still stands today. The turbines themselves came from Newport News Shipbuilding and Dry Dock Company, Francis-type vertical hydraulic turbines rated at 150,000 to 165,000 horsepower each. At full load, water pours through each turbine at 141 tons per second. The Bucyrus Erie Company, which we profiled in a separate documentary on this channel, supplied some of the heavy shovels used in the early excavation phases alongside the Marion equipment. Now we reach the fourth part of this story, the human cost. And if you are finding this documentary valuable, take a moment to like and subscribe so you do not miss our upcoming videos on other legendary construction projects that shaped the 20th century. The Bureau of Reclamation's official count is 77 workers killed during construction between 1933 and 1941. Ongoing research by Jacob Miller at the U.S. Bureau of Reclamation Visitor Center and Susan Dechant of the Northeast Washington Genealogical Society has identified at least 82 deaths. 25 men fell, mostly off the dam itself. 18 were struck by objects. 12 died in vehicle accidents. 9 were crushed. 6 drowned in the Columbia. The deadliest years were 1936 and 1937, with 17 deaths each, roughly 1 death every 21 days. The stories behind those numbers are specific and painful. Arthur A. French, 39 years old, came from New Jersey to support his mother and siblings through the Depression. He was crushed by a concrete block he was stripping in 1937. Ronald Tegmeyer, a nationally known marathon swimmer from Tacoma, described as 200 pounds of young Tarzan, worked as the dam's lifeguard. He had once swum 25 miles from Keller Ferry to the dam site in 3 hours. He fell into the Columbia twice before and came out smiling. The third time, in 1938, his motorboat engine failed and he was sucked into the whitewater below a Cofferdam. Warren Pickle, 20 years old, an WWII foreman, was killed when a cable broke and dropped a heavy concrete form panel onto him. Contrary to a persistent myth, no one was buried alive in the concrete. The dam was built in 50 by 50 by 5-foot blocks, not deep enough to miss a trapped man. But the story of the dam's memorial is almost as disturbing as the deaths themselves. In 1938, sculptor John Sitkovich of Colville carved a 10 to 15-foot granite monument bearing the names of 46 workers killed to that point. It was unveiled at a Memorial Day celebration attended by the governor. But Sitkovich was only paid a retainer. When the American Legion tried to settle for less than agreed, he snapped. One night in June 1940, Sitkovich and his crew drove to Grand Coulee with guns, posted armed lookouts, dismantled the 7-ton monument under moonlight, loaded it onto a truck, and drove away. It took the town days to notice it was gone. On his deathbed, Sitkovich confessed where it was. The monument now serves as a veterans memorial in Colville, Washington. No comprehensive memorial existed at the dam site itself until 2016, when Jacob Miller created one. The last known fatality came decades later, in July 1984, when a teamster named Howard Gum was hauling dirt along Lake Roosevelt, and the slope collapsed. His body was never recovered. His thermos, hard hat, and lunchbox floated to the surface and stood proxy at his memorial. The culture around the dam site was as wild as the construction was enormous. WWII built Mason City as a model company town, touted as the world's first completely electric city. 300 houses painted in varied colors, a 1,000-seat dining hall, a 33-bed hospital, a movie theater, tennis courts, and landscaped parks. Rent was $32 a month for a 3-bedroom house. Drinking was prohibited inside Mason City, but just outside, in the town of Grand Coulee, B Street offered everything Mason City banned. The newspapers called it the cesspool of the New Deal and the toughest town in North America. Ramshackle bars, dance halls, brothels called Pretty Ladies, and restaurants lined an unpaved street that initially had no electricity, no sewer, and no running water. Sewage was channeled to Rattlesnake Canyon, giving the street a distinctive smell that mixed with the dust and the noise of men spending their paychecks. On B Street, a woman of Indian and Filipino heritage and her husband ran the Wu Dip Chinese restaurant. Neither of them knew how to cook Chinese food. They had tried the cuisine on their honeymoon and hired a Chinese chef. Their son, Lonnie Reyes, later wrote the memoir B Street about growing up there. Harvey Slocum's downfall came in the summer of 1937. During a scorching heat wave, he sent a government-paid plumbing crew to install a rooftop sprinkler system on his favorite B Street brothel, the Swanee Rooms. Locals called it Grand Coulee's first air conditioning system. When a reporter wrote that Slocum had been dismissed for ill health, Slocum corrected him. "You put in that paper of yours that I was canned because of ill health. Now you know I got canned because I was drunk." Over 1,000 workers signed a petition for his return. When that failed, they pooled money and bought him a brand new Buick convertible as a going-away present. Slocum later got sober, built Shasta Dam and Bull Shoals Dam, and became chief engineer of India's Bakra Dam in 1952, where he drove a powder blue Cadillac convertible through the Indian countryside. He died in New Delhi in 1961 at age 74. There is another legacy from Grand Coulee that rarely gets connected to a concrete dam in eastern Washington. Henry Kaiser's son Edgar brought Dr. Sidney R. Garfield to the dam site to establish an employment-based healthcare system. Workers paid a fixed monthly deduction for medical care at a small on-site hospital. After the dam, Kaiser replicated this system at his wartime shipyards. It became Kaiser Permanente, now one of America's largest healthcare organizations. Grand Coulee Dam is literally the birthplace of the modern HMO. Now we arrive at the fifth and final part of this story. This is the part that transformed Grand Coulee from a controversial public works project into a weapon of war. Congressional opponents had called the dam a white elephant, a colossal uneconomic folly born of deceit. Representative Francis Culkin of New York sneered that up in the Grand Coulee country, there was no one to sell power to except coyotes and jackrabbits, and there never would be. Eleanor Roosevelt, visiting the site with Franklin Roosevelt in August 1934, remarked that it was a good salesman who sold this to Franklin. The first main generator, a 108,000 kilowatt Westinghouse unit, came online on October 4, 1941, 2 months before Pearl Harbor. There was no ceremony, just a brief wire service story. Westinghouse had built 3 of these generators at $2.6 million each. At the time, they were the largest generators ever constructed. Each could produce enough electricity to light all of New York City. After Pearl Harbor, everything changed. 2 generators originally built for Shasta Dam were diverted to Grand Coulee. They arrived spinning in the wrong direction, requiring rerouted penstocks. The first was installed on February 25, 1943. The second on May 7, 1943. In 1940, the Pacific Northwest had 0 aluminum manufacturing capability. By 1946, the region produced 36% of the nation's entire aluminum output. 1/3 of all aluminum used in wartime aircraft was smelted with Grand Coulee power. But the most secret use of Grand Coulee's electricity was happening 90 miles to the south. In late 1942, Colonel Franklin Matthias selected Hanford, Washington, for plutonium production. A decisive factor in choosing the site was a high-voltage power line from Grand Coulee to Bonneville that ran directly through it, with an electrical substation on its edge. 3 plutonium reactors went operational between September 1944 and February 1945. Plutonium from Hanford fueled the Trinity test on July 16, 1945, and it fueled the Fat Man bomb dropped on Nagasaki on August 9, 1945. On March 10, 1945, a Japanese Fugo balloon bomb, a paper and rubberized silk device carried across the Pacific by the jet stream, struck the high-tension transmission line between Grand Coulee and Bonneville Dams. The power went out at Hanford. Automatic safety mechanisms that had never been tested kicked in. Steam backup pumps maintained coolant water flow to the reactors. Colonel Matthias later said that their controls tripped fast enough so there was no significant heat rise, but it shut down the plant cold, and it took 3 days to get it back to full power. The Japanese had no idea what was at Hanford. The balloon attack was entirely random. A separate balloon fell near Everett, Washington, not far from the Boeing B-29 plant. If you think about what this means, a paper balloon made by Japanese schoolgirls drifting on the wind nearly shut down the most important weapons project in human history. The dam's electricity also fueled Boeing's Plant 2 in Seattle, which produced 6,981 B-17 flying fortresses, up to 362 per month at peak. The plant was camouflaged with a fake neighborhood on the roof, plywood houses, canvas buildings, and chicken wire trees, nicknamed Boeing Wonderland. Henry Kaiser's 3 Pacific Northwest shipyards produced over 750 ships, running 24 hours a day on cheap hydroelectric power. Harry Truman said in 1948 that without Grand Coulee and Bonneville dams, it would have been almost impossible to win the war. There is one more story we need to tell before this documentary ends. The story that is the hardest to tell, and that most accounts of Grand Coulee leave left out entirely. Kettle Falls on the Columbia River had been used as a fishing site by Native American tribes for at least 9,000 years. Up to 14 tribes gathered there during salmon season. A Jesuit priest named Pierre Jean de Smet observed Indians catching up to 3,000 fish per day in the 1840s using 20-foot poles with basket traps. The dam was built without any fish passage. No fish ladder. It permanently blocked over 1,100 miles of natural spawning habitat. The legendary June hogs, Chinook salmon, that regularly weighed over 80 pounds, went extinct from the Upper Columbia. Until 1946, salmon kept appearing at the dam's base, trying to get upriver. After 1946, none were ever seen again. Kettle Falls slipped beneath the waters of Lake Roosevelt on July 5, 1941. It now lies 90 feet below the surface. In June 1940, a 3-day event called the Ceremony of Tears drew 8,000 to 10,000 people from tribes, including Colville, Tulalip, Blackfeet, Nez Perce, Yakama, Flathead, and Spokane. 6 chiefs spoke through a loudspeaker system on the final day. The dam flooded 21,100 acres of reservation land, displacing roughly 2,000 Colville tribal members and 250 Spokane tribal members. The Colville Confederated Tribes won a lawsuit in 1994, receiving $53 million plus $15.25 million annually, beginning in 1996. Chief Jim James, the same San Poil tribal leader who had participated in the 1933 groundbreaking ceremony, was invited to press the button starting the first generator on March 22, 1941. A man who had lost his people's ancestral lands helped turn on the machine that drowned them. In May 1941, the Bonneville Power Administration hired folk singer Woody Guthrie for 30 days at $266.60, roughly $21 per song. A Bonneville Power Administration employee drove Guthrie in a 1941 Hudson Hornet along the Columbia. In those 30 days, Guthrie wrote 20+ songs, including Roll on Columbia, which became Washington State's official folk song in 1987, and Grand Coulee Dam, set to the tune of Wabash Cannonball. Guthrie's songs say nothing about the salmon or the tribes. They were propaganda for public power. If you have enjoyed this documentary, take a moment to like and subscribe so you do not miss our next video. We cover the history of heavy construction equipment, mega projects, and the machines that built the modern world. Grand Coulee Dam stands 550 feet tall and stretches 5,223 feet across the Columbia Valley. It contains 11,975,521 cubic yards of concrete. Today, it generates 6,809 megawatts across 3 powerhouses, producing 21 billion kilowatt-hours annually. It remains the largest hydroelectric facility in the United States. The machines that built it represent a turning point in construction history. The transition from Hoover Dam's cableway system to Grand Coulee's trestle-mounted rail and crane system was not just an engineering choice. It was the moment the industry moved from adapting to terrain to overwhelming it with industrial-scale logistics. The Clyde-Wiley whirley crane standing in Richmond, California, the Davenport locomotives scattered across the country, the 10 million cubic yard waste sand pile still visible from the air. These are the surviving fragments of a 9-year effort that consumed more concrete than any project before or since, killed at least 77 men, drowned 9,000 years of native history, and then quietly powered the weapon that ended the deadliest war in human history. Every cubic yard, placed at the rate of 1 every 4 seconds, carried a story, and most of those stories had never been properly told. Until now.